what sine, cosine, and tangent really meant. So we're going to spend a little bit of time talking about sine, cosine, and tangent, so I really understand what's going on here. So, gentlemen, are you ready?
Yep.
Thanks. All right. So I was walking my dog one day, and I was walking my dog down the street, and just because it was super sunny, and this was in Tucson, and it's always sunny, the sun was out. So here's Mr. Sun. And I happened to cross in front of a flagpole. So here's this lovely flagpole. There we go. Stars and stripes are forever shining. Okay. But because, the sun is shining so much, the flagpole is casting this amazing shadow along the ground, right? And the flagpole is nice and straight, perpendicular to the ground. We got this shadow of the flag, and it happens that I'm walking past it, and I happen to notice my curly hair just met up with my shadow, lined up with the tip of the shadow of the flagpole.
Can I have a nurse? I think my ear's bleeding.
Yeah. You've got a Kleenex there. Yeah. All right. And so let's see. So I'm walking along, and I'm like, holy cow! My shadow is just totally matched up with the shadow on the flagpole. Well, I also happen to be walking my dog. So I got my dog leash here, and I got my little dog, Cleo. Cleo was the coolest dog. Yeah, she's no longer with us. All right. And then I also happen to notice right at that exact moment, all three of our shadows met right here at the tip of the shadow of the flagpole. Well, there's this lovely little triangle right here that connects the flagpole and me and doggy Cleo. And let's see, we have some information here. So I am exactly 5.5 feet tall. So I'm 5.5 feet tall, exactly 5.5 feet tall. And at the moment that I notice this, because I always have a tape measure with me, I was exactly 10 feet from the flagpole. And I also happen to measure that my shadow happened to be 6.5 feet long. All right. Now, we should also know that Cleo's shadow was 2 feet long at that single moment in time. It was pretty miraculous. And what I want to do is I want to figure out what is the height of my flagpole and what was Cleo's height at the time. So I'm going to use a C for Cleo. And of course, all of these are right triangles. And so this is the really important part, that understanding of where trigonometry comes from and how it was observed. So trigonometry and geometry win. They called dibs. They were first. When we think about how math came to be, geometry, trigonometry, algebra many years later, okay? And so people back then actually observed things. They paid attention, and they noticed things. Things like this where we have a lot of right triangles, and in this single moment in time, they are sharing this common angle right at the top here. How many triangles do you see? 3. We got a baby, we got my triangle, we got the flagpole's triangle, right? Okay, so what I want to do, we have, because they all have a right angle, and they have this angle in common, that angle of elevation to the sun, these are all similar triangles by angle similarity. Because they're similar triangles, I can use that information to solve proportions. I want to figure out the height of the flagpole. And so what I'm going to do is I'm going to look at my triangle, and I notice that I have my height, and I have my shadow length. And so what I'm going to do is I'm going to create a proportion using height and shadow length. My height was 5.5 feet, and my shadow was 6.5 feet. And I can use the corresponding sides to figure out the height of the flagpole. I don't know what the height of my flagpole is, so that's F. What was the length of the shadow of the flagpole? 16.5. Why 16.5? Yeah, the whole shadow was 16.5. Okay. Now how do we solve for f here? Yeah, we can cross multiply, or really just multiply by 16.5 is really all we need to do. Will you plug that into your calculator and figure out what that f is for me? All right, 13.96, that's probably good enough. All right, 13.96, fabulous. So the height of the flagpole is almost 14 feet. Probably was 14 feet with error there. Let's see, I also want to figure out Cleo's height. So I'm going to do the same thing, my height to my shadow, and I'm going to compare that to Cleo's height and Cleo's shadow. Will you please go ahead and figure out Cleo's height? 1.692307. All right, 1.69. That sounds pretty good, yeah. All right. All right, so Cleo's height, Cleo, 1.69, you said? Yeah. Okay, so Cleo's height was 1.69. So that's great. What does it all mean? So, again, they observed very cool things. And so many moons ago, they said, hey, I noticed something. There's a pattern here. If I compare the ratio of all the heights to all their shadows, all right, let's see. If I compare my height to my shadow, what is 5.5 divided by 6.5? What do you get? 0.85? Okay. The ratio of my height to my shadow is 8.5. All right, what about Cleo's height to Cleo's shadow? So Cleo was 1.69 and her shadow was 2. So what's that ratio? 0.85. Holy moly, 0.85, huh? What about the flag? The flagpole's height was 13.96 and the shadow was 16.5. What's that ratio? What? So you're telling me the height to the shadow of every triangle up there has the same ratio? Does that kind of blow your mind? Okay, doesn't blow your mind? Blows my mind. I was floored. So now my question to you is, are there only 3 triangles in this situation? No. Could I make a triangle there? Yeah. Could I make a bigger triangle than the flagpole? Sure, I could. I could babysit a building, right? And all the way to the sun, there's an infinite number of triangles. Imagine, okay? And what is the ratio of their height to their shadow? Every single time, right? Is that kind of crazy? So they observed that when we take this side and that shadow side, we have this common angle. And if we know this angle is the same for all of these triangles, the ratio is always going to be the same. So, and what they did is say, hey, let's use a word. Let's make up a word to recognize that ratio. So the word that they used in this particular case, tangent actually, but that's okay. We have our angle right here. So let me make sure here. I have a right triangle, and if we know our angle measure, there we go. If we know our angle measure, then what we have is, first, we know we have a hypotenuse side, and I can call this other side, what do we call it? The opposite, yeah, opposite side. And then here we have the adjacent side. And so what they said was, well, hey, this particular picture, we were doing opposite over adjacent. We're going to call that the tangent ratio. And so the tangent of some angle is the ratio opposite over adjacent. And it's the same, if you know that angle, that ratio opposite over adjacent is the same for a billion triangles. Always the same, okay? And then, hey, maybe we've got a different pair of sides we're comparing. If I knew the hypotenuses, I don't know. it's the question for the millennia, all right? I think it is hypotenuses. I would think it'd be hypotenuse, but I don't know. Does it say? It is hypotenuses. Isn't that weird? It's like I got a hippopotamus for Christmas. Hippopotamuses. All right. Now, so tangent is opposite over adjacent. If we knew the hypotenuse, and we took the ratio opposite over hypotenuse, again, that ratio for all of these triangles would be the same. It's not 0.85, it's a different ratio. We're going to call that the sine ratio. So the sine of some angle is the opposite over hypotenuse. And then cosine, boy, I smushed this in here. The cosine is the ratio adjacent over hypotenuse. So I really smushed those in. Sorry about that. Spacing is. And so these are the three big sine, cosine, and tangent ratios that we want to know really, 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 really good. But this is where it came from. They said we need a name that tells me which sides of the triangle to use. And that's all those words mean. And for me in high school, that was my big question. I was like, but what does it all mean? What does sine mean? It's telling you use these two sides, opposite and hypotenuse. That's all it says, okay? Now we have a lovely mnemonic. My mnemonic for this is so. And I write it this way, so. You should write it this way too. Ka and toa. SOHCAHTOA is how we write this so that we remember. There's little equal signs in here. Now, the really important part is I never, ever, ever want to see sine blank equals 24 over 37, okay? You can never have a sine, cosine, or tangent without an angle. The angle is clutch. You cannot figure out what those ratios are without knowing this angle. And here, it's the angle to the sun. All right? So that angle is super important. So no laziness when you're writing sine, cosine, tangent for me. And also, I don't want to hear sin. Math is not a sin, okay? All they did was say, I only had room for 3 letters on that button. So they dropped the E. It's not sin, it's sine. It's not cos, it's cosine. And it's not tan, it's tangent. Okay? All right. Okay.
Sin, cos, and tan.
You're deported. Get out.
Get out.
Okay. All right, ladies and gentlemen. So sine, cosine, tangent. Now, those are the 3 big ones. We also have what are called the reciprocal functions. This is cosecant. This is cosecant. This represents secant. And this is cotangent. Because cosecant, secant, and cotangent ratios are reciprocals of sine, cosine, and tangent functions. They are called reciprocal functions. Cosecant of some angle is really just 1 over the sine of the angle. So if you were ever asked, like, what's the cosecant of your angle? Well, let's say you don't have a cosecant button on here. No, it's not. Yeah, it's not. So if you had to evaluate what's the cosecant of 24 degrees or something like that, you would have to type in your calculator 1 over the sine of 24 degrees. You do not have a cosecant button, all right? So that's really important that you know that those are reciprocals. So secant of some angle is really 1 over cosine, it turns out to be. And then cotangent is 1 over tangent of your angle. And that's the only one that makes sense. How do you remember what goes with what? Cosecant starts with a C. It goes with the sine. It has an S. All right? It's a C and an S sort of pair that sort of go together. Here we have secant and cosine, C and an S, okay? And here, well, this is cotangent and tangent. Now it doesn't kind of work the same, but those are reciprocal functions. Well, if you're doing a reciprocal, what happens to your ratio here? So sine of some angle is simply opposite over hypotenuse. What is 1 over opposite over hypotenuse? I don't like dividing by fractions. What can I do? Multiply by the reciprocal. Yes. So what we're actually doing then is flipping this. We're going to multiply top and bottom by the reciprocal. The real math here is that these cancel each other out in the denominator, and we get 1 times hypotenuse over opposite. It just turns out to be hypotenuse over opposite. So the end is they flip. They are the reciprocal. So what does 1 over cosine of theta turn out to be? Hypotenuse over adjacent. And what does 1 over tangent turn out to be? Adjacent over opposite. So they just flip. All right. So ultimately they just flop. Okay? So we had a big 6 functions here, but SOHCAHTOA is really the main 3 that I'm pretty much always going to start with. So we want to find the exact values of all 6 trig functions of theta. What is the sine ratio? Yeah, so this is going to be opposite over hypotenuse, so that would be 12 over 13. What's the cosine ratio? Yep, adjacent over hypotenuse, yep, so 5 over 13. And what's the tangent ratio? 12 over 5. All right, and so what's cosecant going to be? 13 over 12. And secant? 13 over 5. And cotangent? 5 over 12. So really easy. Once you have your big 3, getting the reciprocal functions is pretty easy. All right, let's look at number 2 here. Because you need to learn how to rationalize. Yeah, sorry. All right, sine. Looking from this angle here, we have the hypotenuse, and always identify your opposite side, opposite your given angle. That leaves adjacent remaining. All right, so sine is opposite over hypotenuse, so that would be 4 over 4 root 5. So not 4 root 5, actually, the 4 is fine. But we do have to get rid of that radical 5, so we have to rationalize. What happens with these 4s, do you suppose? They do reduce, all right? So they happen to cross out, which is kind of nice. So we do get radical 5 over just 5, yep. Radical 5 times radical 5 is radical 25. And what's the square root of 25? 5, okay. Cosine is adjacent over hypotenuse, so that would be 8 over 4 root 5. Tell me about the 8 and the 4. They reduce, so we get a 1 and a 2, so that's 2 over root 5, and then what do we have to do? Times by radical 5, top and bottom, and so we get 2 times radical 5 is 2 radical 5. And what do we get in the denominator? Just a 5. So 2 root 5 over 5. She really gave us a ton of space to work in there.
He wants me to go back because it's not stopping.
Not stopping. All right.
Does that mean that's 30 degrees and 60 degrees?
No.
This triangle?
Nope.
Which one is it?
Neither. Which one is what? You mean it's not a 30, 60, 90? It can be anything, right? Anything.
I thought we could,
It's if it were a 30, 60, 90, it would. This would have the root 3 on it. Yeah. All right. Tangent is opposite over adjacent. That's 4 over 8, which reduces to 1 over 2. All right. Cotangent. I'm going to flip my fraction. It just becomes a 2, which is nice. Secant. I don't want to flip this. That's the hot mess again. But you'll notice back here, I had 2 divided by radical 5. Right at the beginning. Do you see that? 2 over radical 5. I can flip that. Radical 5 over 2. And avoid rationalizing again. And then back here at the beginning, the 4's crossed out, so that became a 1 over radical 5. So radical 5 over 1 or just radical 5? All right. Ooh. Let's look at number 4. What's missing in this picture? The hypotenuse. What do you suppose we need to do? Figure out how to, how do we get it? A squared plus B squared equals C squared. Good. We've got to figure out that hypotenuse. So how do we do that? We've got 6 root 3 leg squared plus leg squared equals the hypotenuse squared. This is 6 root 3 times 6 root 3. When you write it out 2 times, what does that give you? 108. How did you get 108?
6 times 6 times that by 3.
Yeah, so radical 3 times radical 3 is just 3. And 36 times 3 seems like 108. That's good. All right, equals 36. Oh, 6 squared is 36, sorry. And those together give me 144. And then how do we get C by itself? Square root, so we get C equals 12. All right, so our hypotenuse is 12. What's our sine ratio? 6 root 3 over 12. So opposite over hypotenuse. And that can reduce, yes. The 6 and 12, 6 goes into 6 once and 6 goes into 12 2 times. So we get radical 3 over 2. Cosine is A over H, so that's adjacent over hypotenuse. 6 over 12 is 1/2. And then tangent over 6, yeah. And so the 6's are going to cross out. So it's just root 3. Okay. Now, if I flip all those, cosecant is going to be 2 over radical 3. What do you have to do? Multiply by radical 3, top and bottom. And that's going to give you 2 root 3 over 3. Secant becomes 2, and then cotangent, well, I got to flip that. Right now it's radical 3 over 1, so it becomes 1 over radical 3. Got to rationalize, so multiply both sides by radical 3, top and bottom. And we get radical 3 over 3. All right, questions on those? Do you remember how to simplify radicals?
Yeah.
All right, so you go, like, if you had the square root of 98, it'd be like 49 times 2. Yeah. And then the square root of 49 is 7. Yeah? Okay. So you will have to do that. Turn the page. And then we're almost done here. All right. Use the given trigonometric value to find the remaining function values. And we have here a little note. I told you to draw the triangle. And I used to do this. I'd be like, hey, look, it's you have a trig function right there. And it's kind of in the shape of a triangle. And so what that's going to tell you to do is, hey, we can draw a triangle, a right triangle, and I'm going to go ahead and draw my angle theta somewhere. It doesn't really matter. So this is the tangent ratio according to my angle theta. Tangent is opposite over adjacent. I'm going to write down my SOHCAHTOA so I can have it referenced easily here. All right. So that is the opposite side over the adjacent side. So where should I put my 7 on my triangle picture here? Opposite. Opposite my theta. So there's my 7. And where does the 24 go? The base. And so what am I missing? The hypotenuse. Oh, hey, it's 25. How did I get that? It's a Pythagorean triple, 7, 24, 25. It's just a nice one. There's another 5, 12, 13 is another Pythagorean triple, and then 3, 4, 5 is another Pythagorean triple. They just work out real good. They're good to know. But yes, you could do the Pythagorean theorem, but I'm going to save time. What's the sine ratio now according to this picture that we drew? 7 over 25. Opposite over hypotenuse. Cosine is adjacent over hypotenuse. So 24 over 25. And tangent they told us. And then what's cosecant going to be? Yeah, the reciprocal, 25 over 7. And then secant will be 25 over 24. And cotangent, 24 over 7. Good. Alrighty. Let's do one like this. Number 8. Secant. It is a 4 over 1. That's true. And secant is, I could put it in here, but secant is related to cosine, which would be what? 1 over 4. Oh, that's kind of nice. I could do that. Okay. So I think I can draw this picture. So I'm going to go ahead and draw my little triangle. Here's my angle theta. Cosine is the ratio adjacent over hypotenuse. So let's see. That means the hypotenuse was a 4 and the adjacent side is the 1. What should I do? Pythagorean theorem again? Yeah. All right. So we want to figure out this side. I'm going to call it b. 1 squared plus b squared equals my hypotenuse squared. So 1 plus b squared equals 16. Subtract 1, so we get b squared equals 15, and then square root. Does that simplify? No. 5 times 3, there's no perfect squares in there. So this is radical 15, and it doesn't simplify. All right. So sine is opposite over hypotenuse. So radical 15 over 4. And tangent is opposite over adjacent. So radical 15 over 1. All right. What's cosecant? 4 over root 15, which becomes what? 4 root 15 over 15 once you rationalize. Yes. And cotangent becomes, yeah, radical 15 over 15. You will have to rationalize in Delta Math, so pay attention to that. Do you have questions for me? All right. Yeah.